Okay, hello everyone. We're gonna derive something called the quadratic formula today. The quadratic formula is used. It's used to solve quadratics. Remember, that means degree 2 equations. We already have two other ways of doing that. We have factoring, and we have completing the square. Which we did last time. So the third one is quadratic formula. But first we have to derive it. So we started doing this in class last week, and I got most of the way through for, I think, 3 of the classes, and maybe halfway through for one of them. So I'll quickly go through the first half of the derivation. So we started with this, and we're solving for x by completing the square. So normally you divide by a first, because the coefficient of x squared has to be 1 if you're completing the square. And then we move the c over a to the other side, because we're getting ready to put the magic number in the box to complete the square on the left side. We take half of b over a, and then we square that to find that magic number. And there it is. And then I add it to the right as well. Okay, the left side is now a perfect square, so I can factor it. The right side, right now all I'm going to do is switch places these two terms. Okay, then I'm going to take the square to both sides, and this is where I stopped for I think 3 of the classes. Okay, now we basically have to do 2 things. We have to simplify what's in the rad, and then we have to bring that b over 2a to the other side. So I'm going to do both at the same time. So in the rad I have 2 fractions. The least common denominator is 4a squared. So I've got to multiply this c over a by 4a over 4a. And then I get that. And I can do something else here. So I can split this fraction into a rad over a rad. And then I can simplify the 4a squared, which is rad 4a squared. I can simplify rad 4a squared to 2a. The top stays the way it is. And now I can add those 2 fractions. And the denominator is now rational. So this is as far as we can go. This is quadratic formula. And that's our third method of solving a quadratic equation. So how would we use it? Well, let's say our quadratic, for example, is 7x squared minus 6x plus 1 equals 0. Okay, so first of all, remember that all these variables in the formula come from these two coefficients and this constant, which means that your equation must be in this form in order for you to use the formula. If it's not in this form and you want to use the formula, you've got to put it in the form, okay? Because when you move stuff around in equations, you know, these a's, b's, and c's, they're going to change. Luckily, this equation is in the right form, so a equals 7, b equals -6, and c equals 1. And then I just plug these three values into our formula down here. So, according to the formula, x equals -b. b is already -6, so 6 plus or minus. And I leave the plus or minus in there because x is going to be two values, right? Plus or minus b squared minus 4ac over 2a. And then simplify. Here I have a GCF of 2 in the top, so I can take the 2 out. And then cancel it with 14. So there we go. Those are the two answers. X equals 3 plus rad 2 over 7 or 3 minus rad 2 over 7. Now, let's compare with the other methods if you wanted to use the other methods for this. First of all, factoring, you can only use if the trinomial is factorable. In this case, it is not, because you can't find two numbers with a product of 7 and a sum of -6. A product of -7 and a sum of -6 would work, but product of +7, sum of -6 can't do it. So this one's not factorable. How about completing the square? Yes, you could do completing the square, but in order to do completing the square, the coefficient of x squared must be 1. So if you want to do it that way, the first step here would be to divide everything by 7. And if I did that, I'll put it up here what I get. X squared minus 6/7 x plus 1/7 equals 0. And then you go ahead and complete the square from there. But if you know anything about the steps of completing the square, if you've got fractions like 6 over 7 and 1 over 7, it's not that fun. Unless you like love fractions with prime number denominators. So each of the methods have their pros and cons. If it's factorable, of course, go ahead and factor. If the numbers are nice, you can factor or complete the square. If you've got a situation like this where the numbers are not nice, a is not 1, you've got at least one prime number in there. And if the numbers are not large, too large, quadratic formula might be the better choice. So you have to look at the big picture, consider the pros and cons of each method, then pick a method. Okay, so that's solving by quadratic formula, and that'll be the last method we have for solving quadratics.